Hello, and welcome to the Trepid Technologies Security Plus course. My name is Johnny Bandon, and I will be your instructor for this video series. This video will cover Domain 2.1 Enterprise Security Concepts. Now let's get started. So the first thing we're going to talk about is configuration management. Configuration management is a concept that standardizes version control, operating systems, and systems within your enterprise. For example, you may implement configuration management on all your clients in the R&D department by creating a custom image of Windows 11 with all the necessary security policies and applications already installed. So really what configuration management is, it's just a term to describe a process or system that is going to standardize something in your network. And typically that something is either hardware or software. So anyone that's ever worked in IT, well, I shouldn't say IT, but worked the help desk or system administration, has probably used what we call an image or a bootable USB. And you can make a custom image that fits the needs of a department or an organization. So you can create a Windows 11 image that already has pre-installed software, maybe some security policies already on it that make that system already hardened or easier for the user once they get their system. And this definitely helps if you have multiple departments that need reimaging. You can have an image for each department. Or even in the government, we'll have images for certain classifications. So you'll have an image for your secret network. And this image, again, is the operating system for a computer. And you'll have an image for your unclassified network. Another important concept in configuration management is documentation. And one document that we're going to talk about is a diagram. So diagrams are a great way to document your network. There are many different ways to diagram a network, many different applications that can help you create diagrams. A common one that you create manually, or a common software that you can use to create a manual network diagram, is Microsoft Visio, which is part of the Microsoft Office suite that you can purchase. This is great if you want to create a logical or a physical network diagram. And you have logical network diagrams that'll just show you kind of stuff like this, the server, how it connects to the switch, what port. You could even have maybe the subnet between the two or the VLAN it's on. And then you have physical diagrams that may show you physically where these servers are located, right? So you may have a diagram that shows a building, and you can say on the second floor, room 2 is where our server rack is. Then even some applications, like some SNMP applications or network monitoring tools and applications, can also dynamically build a map of your network, which will enable you to automate the building of your network diagrams. Some tools that I have used in my enterprise or in the past have been NetBrain or Ford Networks. NetBrain, if you guys want to check them out. Ford Networks. And this will actually just do auto discovery of your network and show you all the paths on your layer 3 down to the layer 2. So there's a lot of different ways we can diagram our networks. So more configuration management is the baseline configuration. And this is a standard that IT or cybersecurity personnel implement and enforce to have default security and policies across all their systems. So the baseline configuration could be a naming convention, the IP schema, which means pretty much, okay, is our default gateway going to be the first? Or we could even have a chart like this saying the router is going to be .1, switches will be 2 through 10. This also could be involved with IPAM, your IP address management system. Just some examples of baseline configurations. This could also be some group policies that you implement on the network as well. And then we also have geographical considerations as part of our enterprise security concepts. So deploying infrastructure and services in today's environment does look a little different than it did in the 90s or early 2000s. Companies with global customers must adhere to compliance and regulations of the area where they process customer data. And with developing nations, now data sovereignty laws are becoming a huge deal and a big part of data processing. So, with the surge of cloud technology in today's IT landscape becoming commonplace, where we can deploy an application in the EU region within a matter of minutes, we must understand the data sovereignty and how we must protect and deploy services in another country. For example, in the EU, we have to comply with the GDPR, which are data protection laws for all EU customers. In the US, if you process credit card data, you must comply with the PCI DSS compliance and regulation. If you want to work on government computer networks or systems, you must follow NIST standards. And then we have some data protection. Another important concept that cybersecurity administrators must understand. Protecting your sensitive data from leaving your network or protecting your network from malicious software being installed on your system is a form of data protection. And there's a lot of different controls we can use on our network to protect our data. What we're going to talk about here is something called DLP, or data loss prevention. This is a technical control that is very common to protect sensitive data from being exfiltrated. DLP is software that can be installed at the network entry and access points. So on a firewall or maybe your router. Well, maybe not a router per se, but on the exit of that router, the demarcation point. It can also be configured on your endpoints, meaning your computer systems or your servers. And they are configured to prevent the exfiltration of data, right? So we can install a DLP agent on our computer here, and this can prevent, let's say, social security numbers, right? You can configure that DLP agent to stop any file that has this pattern from leaving the system. You can also configure DLP to prevent any USBs from being plugged in. On government systems, this is an important control that they have in place. We don't want any USBs with potential malware being plugged in. So if a USB does get plugged into the computer, DLP will go ahead and shut that USB port off, and then maybe send an alert to our antivirus, anti-malware solutions, and alert cybersecurity administrators of a rogue device being plugged in. Another thing you can do is configure DLP on your email gateways to prevent sensitive data like PII or PHI from leaving the network. This PII standing for personally identifiable information, and then PHI being protected health information. And we'll talk about these two later on in the series more in depth. And then we have response and recovery controls. So having hardware or software failures in IT is something you will come across in your career. It's bound to happen, right? And we're talking in this domain enterprise security concepts. You may be wondering, well, how is a failure a security problem, right? You must always remember the thing that guides us, the CIA triad and privacy, of course. That A in the CIA triad is availability. So as a cybersecurity administrator, you must take it upon yourself to make sure that you have processes and recovery controls in place in case of that failure. So there are several different ways to have backups and redundancy in your network. Snapshots, full, incremental, and differential backups, RAID, and hybrid cloud deployments. All these are examples of redundancy, which we'll cover more in depth later in the series. CompTIA wants you to know about non-persistence and horizontal scaling for this slide and section of the Security Plus exam. Non-persistence is commonly referred to as a last known configuration. A last known configuration can save you after changes in your network bring down a system. Now, a lot of you that are more senior or have been around the game a little bit may recognize this as maybe like a snapshot or a full backup. Really, what non-persistence is just a term to describe these different technological controls we can have to restore a system, right? We just call that non-persistence. And the layman's term for that is the last known good config. For you guys out there that work in networking, you make a change on a Cisco device, you could do show startup, and that'll show you the last known good config if the change you made in the running config brought down your system. And then we have horizontal scalability. Horizontal scalability allows you to remove or add compute and storage resources as you see fit. This is typical of cloud deployments where you can add resources to infrastructure all from one cloud console. So when we talk about compute and storage resources, compute resources is going to be CPU and RAM, stuff that does all the processing, all the threading, right, for whatever application you're using. And then storage, this is going to be your hard drive space or your solid state space, everything that stores your information or data. And then we have some data in transit encryption protection mechanisms. So we have SSL and TLS. They're both encryption methods that secure your data in transit. SSL and TLS encapsulate your IP header with encryption and create a secure tunnel between client and web server. We're going to go more into depth in SSL and TLS later in this series, show you the cipher suite that we use to actually encrypt data in transit using TLS or SSL. Some key notes you need to know for the exam and for the Security Plus exam objectives is that SSL technology or TLS, it is a VPN because it uses tunneling technology. It's going to encapsulate your IP packet to protect your data payloads between client and server, making it a VPN. And then we also have different versions. So TLS 1.2 and 1.3 are the most secure versions, with 3 being the most secure. 1.1 being outdated and non-secure. And remember, these are TLS versions here. SSL being completely outdated. And if you are still using SSL, you might as well not use any encryption at all. So the best protection in the TLS encryption suite is going to be 1.2 and 1.3. And then some more security concepts. Here we have hashing. So hashing is an essential concept in cybersecurity, or concept or actual control. Hashing ensures our data has integrity and is used in the forensic process for incident response as well. What hashing does is it takes an input, whether that's text right here like we see, or even a data file, right? And then runs a hash function on that input. So that could be a SHA-256 algorithm, right? That hashing algorithm. And then the output is going to be a unique string, which we call a digest, or sometimes we call a checksum. So this isn't converting this hello world, right? We're not doing transposition here. This is creating a unique digest from your input's information. And then we can use that digest to verify that our input, our file, or our text hasn't been changed. So, for example, if you send a file or a .exe via email, so let's say this is you right here, you need to send an exe. So let's say Bob, your name is Alice, and you want to make sure that that .exe doesn't get changed in transit. You want to make sure that Bob can check that this file hasn't been tampered with. You can run a hash algorithm against it. It'll create a unique digest. You can attach that digest to your message, right? I'm going to package this in an email. Once Bob receives that email, he can run that same hash algorithm against your .exe. And if that digest comes out to be the same as the digest Alice sent you, then you know that that file hasn't been tampered with. If the digest comes out different, then you know that data has been tampered with, because you create a unique checksum or digest from information. And if that information changes, then that checksum or digest also changes. You can also use the same function, right? You can do the same thing for when you download files offline that you think may have changed, right? Now let's go over some site resilience. So this is another concept that cybersecurity professionals must take into consideration because the availability of our data is very important to us. If your enterprise is relying on one data center in a geographic region that has, let's say, power outages or reoccurring natural disasters, you may need to take a look in the mirror and start investing or convincing your organization to invest in some resilience. So let's go over the different site resilience terms. A hot site is going to be a functioning data center that can take over services without any downtime or very little administrative intervention. So our hot site is going to be used in our COOP operations. This stands for continue of operations. That's our COOP, right? When we COOP over from our main data center to our backup. And if that COOP takes minutes, we call that a hot site. And then we have a warm site, which is a partially functioned data center that would require configuration and administrator intervention before becoming operational. So you're going to have downtime when you use a warm site. And then you have a cold site, which is a data center that requires complete installation and configuration before becoming operational. Which one you choose is all depending on your business objectives. If the business thinks it is good business sense to invest in another hot site, they'll put down the money for it. If they think they need just a couple hours to get up and operational in case of natural disaster, they'll invest in a warm site. And if they don't really care about resilience and just maybe want some space where they potentially could have a natural disaster they need to fail over, they'll invest in a cold site. And the last thing we're going to talk about is deception and disruption. So deception is another tool cybersecurity professionals have in their toolbox to protect and gain insight into threat actors. A honeypot is one of our deceptive techniques, and it is a decoy network that entices a threat actor to attack. Then once a threat actor has infiltrated and exploited the honeypot, which has no connection to our real enterprise, you can examine their TTPs and learn from the attack. So learn their tactics, techniques, and procedures. That's what we mean by TTP. Tactics, techniques, and procedures. So a honeypot could be entire network. It could be just one server or virtual machine, right? When it's a network, there's a term called honeynet. This wasn't in the Security Plus exam objectives, but later on, if you want to continue with the CompTIA track, if you go over CASP, COISA, they'll call a network a honeynet and a honeypot a singular device. And then another deceptive technique we have or implementation is a decoy file. A decoy file is a file you place on your network with a false title that would entice a threat actor to open it. So an obvious one would be credit card information, right? Obviously, you don't want to make it that obvious, but just a clear example, right, of something you'd name a decoy file, something that entices a threat actor. And once the threat actor opens that decoy file, an alert is sent, and the user who opened the file is logged so you can investigate who and why someone opened that decoy file. All right, so that is it for Domain 2.1 Enterprise Security Concepts. Join us for our next video, which we will cover Domain 2.2 Cloud Computing Concepts. Thank you.